Example 17. A jet issued at the rate of 155 liters per second and a velocity of 35 meters per second strikes a blade moving in the same direction at 20 meters per second. The deflection angle of the blade is 150 degrees. Neglecting friction in the blade, determine the magnitude of the x component of force, the y component of force, and the work done on the vane. So this is the figure to help analyze the situation. So for Fx, it is Q prime rho quantity V1x minus V2x, where Q prime is area times U, and U is V1 35 minus V prime 20. So 15 meters per second. So that's 15 meters per second up to the left. So if the deflection angle is 150 degrees, the angle that U makes with horizontal is 30 degrees. Same is true with this angle here, 180 minus 150. So V2x therefore is 20, then because U is going left, minus 15 cosine of 30. So V2x is positive 7.01 meters per second. The value of Q prime rho is area times V1, area times U, but we don't have area here, but we are given Q. So Q is area times V1, 0.155 cubic meter per second equals area times V1, and V1 is 35. Therefore, area is equal to 0.155 over 35 square meter. So we can now evaluate Q prime times density. So Q prime times density is area 0.155 over 35, then U 15. So this is Q prime, then density 1000. So 66.43 kilogram per second. Substitute into this formula here where V1x is 35. So Fx is 66.43, quantity 35 minus 7.01. So Fx, the x component of force, is 1859 newtons. Just the magnitude, so but specifically it is rightward. Fy equals Q prime rho quantity V1y minus V2y. V1y is 0. V2y is, the y component of V2 is just y component of U, which is 15 sine of 30. And it is 7.5 meters per second. Substitute, Fy is 66.43, quantity 0 minus 7.5. So Fy is negative 498.2 newtons, or Fy is 498.2 newtons downward, or 498.2, just the magnitude. Then the work done on the vane, that's work equals Fx times V prime. And Fx is 1859, V prime is 20. So work is equal to 37,180 joules.